So I'm going to go ahead and review the problems that I discussed in the class for test number 3 that I would like to have gone over had I had the time in class. So the first one I suggested was problem number 5A from homework 5. There wasn't a 5A, so I might want to revisit this later, but we're going to go ahead and do this problem. So the problem said graph the following equation and show it on the graph using the slope and the y-intercepts. Label 3 points on the line and the line appropriately. So the first thing I'm going to do is I'm going to go and I'm going to find the y-intercept. So the y-intercept is -1, so that would be right there on my graph. I have to apologize because I've never found a great way of using my bamboo tablet to graph lines, and it's really hard to actually put points on it on the tablet because it keeps wanting to change pens. So apologies first. So -1, and then I'm going to label that point so that I don't forget to do it later on when I come back. So there we go. And then I'm going to use my slope, my rise of 5, and my run of 2. And one of them is going to be negative and one of them is going to be positive. And remember, I like to use both positive and negative. So I'm going to go up 1, and then 2, and then 3, and then 4, and then 5, and then I'm going to go back 1 and 2. So that place right there is going to be where I'm going to put my point. So there's my second point, and I'm going to label that. That is on the x-axis at -2, and it's with the y at 1, 2, 3, 4. So there's my ordered pair. Now I'm going to return to my starting point, and now I'm going to go down 1, 2, 3, 4, and 5, and then I'm going to go forward 1, 2. And so now I'm going to put a point here, and that point I'm going to label as well. It's underneath x is equal to 2, and it's right next to y is equal to -1, 2, 3, 4, 5, 6. So -6. So there's my 3 points. Now I would tell you to get out a straight edge and make a line that goes all the way through these. I don't have that option on this, so you'll just have to forgive my really crummy looking line. So there's my line, and the last thing I want you to do with it is label it with the equation. Y is equal to -5/2 x, and then -1. So there's my label. Now this all looks pretty crappy. It's been a while since I've used my tablet, so I have to get used to drawing on this thing again because it's not as easy as it may seem because I'm not actually drawing on a piece of paper. So now we're going to move on to our next problem. So the next problem that I'm going to go over is, let me just pause here for a second and figure that out. Just give me a second. So my next place to go over was from homework number 6, and I wanted to go over problem number 3. So homework number 6 and problem number 3. So problem number 3 is a linear equation problem. So it says for the following scenario, give a linear equation, and we are going to use a t-table that gives the ordered pairs. And give 3 ordered pairs that satisfy the story in the equation. So I'm going to move it just a slight bit over this way so we can see both of these at the same time, and then we can get started. All right, so the percentage of students receiving an A in high school, P, was 15% in 1970. This percentage has increased approximately linearly at a rate of 5/6% per year every year since 1970, and that's T. So my P is the percent receiving A's. And my T is time since 1970. Now remember, that's actually very important that it's since 1970 because that means I'm not using the years as the independent variables, but instead using number of years since 1970. So I'm actually given right here, this number right here, that's my increase approximately linearly at that rate. So that means that is my slope. And because these are percentages per year, that's my dependent is percent and my independence years. So that's just giving me my units. So my slope is actually equal to 5/6 is what that's telling me. And then it says furthermore that 15% was the average or the percentage in 1970. So that's telling me my B. My B is equal to 15, and that would be percent. And remember that this is percent per year. So that is going to be my slope. So now I can actually give my equation here. So the first question says give the dependent variable based upon the story above. So A, my dependent, is P. And then the second one says give the independent based upon the story above. And B, T, is my independent. And then what's the baseline? So my y-intercept is the next thing that we need to find. So that's my answer to C right there. And then the next one here, it says what is the rate of change, and that's with units, and we've already done that one. That's D there. And then give the linear equation, and so that's the next logical progression in this process. So you notice that I didn't even read these questions and I was already thinking along these terms. So what I've done with this question is I've walked you through the steps that you need to think of in order to get a linear equation for this problem. So my linear equation is going to start out with P because that's the dependent, and that's going to be equal to my slope, which is 5/6, times my independent, which is T, and then plus my y-intercept, which is 15. And so there's my equation, as E asked for. Now F, I'm going to use 3 values to model this. So in my next one, my F, I'm going to go ahead and I'm going to put in a t-table here, and I'm going to do my independence T's and my dependence P's. So 0 is a good one to have, and that's just going to give me my y-intercept of 15. And then another one that I could put in multiples of 6 here so that I don't get out fractions. So if I went 6 years after, that would give me 5/6 times 6, and then plus 15. So the reason for multiples of 6 is, of course, to get these to cancel. So that's going to be 1. So 5 times 1. So we have 5 plus 15, which is 20. So 6 and 20. And then I can do it again. Let's go with 12 this time because that's another multiple of 6. So 12 here. And so this is times 12. And then canceling, this is going to give me a 2 up here in the top. And then plus the 15. So now I have 2 times 5, which is 10 plus 15. And so that's going to give me 25%. And so those are 3 ordered pairs, and there's no nasty fractions or decimals in there. And I have a very nice equation. So that's the next one. Now, the next problem was number 5 that I wanted to do in this one. So here we have 5, and I think this one was 5, yeah, maybe this one was the 5A. So let me find the correct one again. No, that was 5, and we need 6. So 5A for sure, simplify. Yeah, it was just 5A. So we're going to simplify this one. And our simplification process, we're going to do for this problem, we're going to do 5/6 and then times x minus 1/3 and then plus 2/3. Now this is an expression that we're simplifying, and so we're not going to be able to clear this of equations, and that's one of the things that you might want to be aware of, is that we can't clear the expression of fractions. You can clear an equation, but you can't clear an expression. So we're going to get 5/6 times x, and then minus, and 5/6 times 1/3, multiply the numerators. 5 times 5 is 1, 6 times 3 is 18, and then we have plus 2/3. Now these two are like terms, so I'll have to add them. So I'll have to have a common denominator between 3 and 18, and that LCD is just the 18, since how 3 is a factor of 18. So 18 is my LCD. So I'm going to multiply the denominator by 6 to make that 18, so I have to do the same thing with the numerator. So that's going to give me a 12 up here in the top. So now I see I have 12 and I have -5. So simplifying this completely, I'm going to get 5/6x, and then my plus, and then I have 12 minus 5, and those are going to be 18ths. And 12 minus 5 is going to give me 7, and those are 7/18ths. And that's it. All done. And so now I'm on to homework number 7. Let's see, remember this was number 3 from homework number 6. Okay, so